only going to be a chapter in life, not the whole story. A very good afternoon, everyone. With this optimistic quote, let's start with the next half of our day 2. Without any further ado, I would like to call upon Dr. Srikar Raman, CEO and co-founder, Twastar Jink Lab Private Limited.
So good afternoon, everyone. I'm Srikar. It's been wonderful today, the whole day, hearing about so many aspects of technologies that has been involved in cancer therapy and diagnostics. And here we are on the verge of unveiling one of the latest technologies, which is episcreen-based diagnosis for liver cancer. So we are basically, what we have done is we are accelerating early diagnosis of liver cancer. It's powered by liquid biopsy and molecular diagnostics, and I'm Srikar, CEO and co-founder of Twastar Jink Lab. So HCC, which is hepatocellular carcinoma, it constitutes about 85% of liver cancer, and the rest, about 10 to 15%, belongs to cholangiocarcinoma. And what we are focusing over here is on hepatocellular carcinoma. So HCC is the 6th most common cancer, 4th leading cause of cancer deaths globally. It's about 1 million new cases and almost 1 million deaths annually. And it's ranked among the top 3 causes of cancer in 46 countries, which means this is a cancer which is extremely deadly, but not much work has been going on with respect to HCC. In fact, one of the biggest things in India is, if you actually look at the WHO data, cirrhosis of liver is amongst one of the top 10 causes of deaths in India itself. So HCC, normally what happens is it develops from cirrhotic liver, or any patient who's having a chronic liver disease, they tend to develop HCC. So cirrhosis is actually increasingly becoming a public health priority in India, and it's about 25 million cases. 3% of the total deaths in India and 1/5 of all cirrhosis deaths occurs globally because of this. And almost 80 to 90% of the cases of HCC develop in persons with cirrhosis, which means if you're able to monitor the patients with cirrhosis in a timely manner, there is a good possibility for us to detect hepatocellular HCC at the early stages. So what is this current standard of care? I mean, with respect to the diagnostics, screening and diagnostics, there's something called alpha-fetoprotein, AFP. And the serum AFP is by far the most widely used biomarker, but it's been there for the last almost 40 years. However, if you actually look at the sensitivity, it's about 50%, which means that only 5 out of 10 people who are having HCC, AFP can detect it. The rest 50% go missing, and that's the only reason why you normally see liver cancer cases at a very late stage and not at the early stages. The other one, of course, is the radiological-based diagnosis for HCC, which is CE, CT, MRI, etc., which also has a sensitivity of 75 to 80% with a specificity of 90%. So both these guys have a good amount of specificity, but the sensitivity is just not good enough for, at least for the blood-based marker, for it to detect the cancer at the early stages. So AASLD, which is the American Association for the Study of Liver Diseases, actually recommend HCC surveillance every 6 months in at-risk patients, including those with cirrhosis. So this is a program which has been going on for a while, and all the doctors normally, hepatologists, follow this, that they do a surveillance, they look at the blood parameters, etc. However, when they look at the AFP, it's always almost 50% of the cases it's negative, and hence they miss out on HCC cases. So what do we do about it? So we thought of, instead of going into mutations normally is very heterogeneous when it comes to hepatocellular carcinoma. So we looked at something called methylation patterns, which is epigenetic aberrations. Now there are 2 types of genes, tumor suppressor genes and proto-onco genes. And tumor suppressor genes is where the hypermethylation of the genes occur, causing gene silencing. And so the suppressor genes are silenced due to hypermethylation, causing either tumorogenesis or it causes either the tumor to proliferate. So we are using methylation, which is an epigenetic mechanism through methylation, basically an epigenetic mechanism through which a methyl group is added to the cytosine residue, and the disrupted epigenetic process causes malignancy in cells. So what we have done is something called episcreen liver. It's a simple blood-based molecular diagnostic test for HCC, and it is first of its kind in the world. So this test is not available anywhere, and we have developed it in India, and we have validated it in more than 500 patients now. So I will go into the technical details of that. So what do? We take a blood sample, we extract the plasma out of it, and then isolate the cell-free DNA. And then what we have done is we have used the aberration of the epigenetics, that is hypermethylation DNA. We have combined these two things in order to make a episcreen liver, which is a 4-gene multiplex panel that screens for HCC. So we started off with about 24 genes and boiled it down to about 4 genes, wherein 24 combinations and boiled it down to 4-gene multiplex panel, so that it can be affordable and it can be used everywhere. Because what we are doing is we are using droplet digital PCR, which is accessible in many places, unlike something like next generation sequencing, which is expensive in nature. So the clinical relevance of episcreen liver is methylation analysis that can be beneficial to the clinician. It can improve the accuracy and timing of the diagnosis. It can provide prognostic information, as well as it can offer a potential means for cancer therapy. Because US FDA right now is on the works of developing treatments based on epigenetic aberration, specifically hypermethylation. So this is a profile that you can see. So it's on the left side, the top panel is for a non-HCC chronic liver disease patient. The first one is histopath data, the second one is the CECT imaging, and the third one, as you can see, is the droplet digital PCR, ddPCR profile. So for a non-HCC patient, the blue droplets that you actually see are the ones which represents the hypermethylation in the DNA. So there are the first two panels of the C, F, and I images represents unmethylated standard and methylated standard. So unmethylated standard, you don't see any kind of unmethylated, there's no blue droplets observable, which means there is no methylation. And methylated standard, of course, you see a lot of blue droplets, which means all these DNA are methylated in nature. So the last one is the sample. So if you actually look, in the case of non-HCC chronic liver disease patients, there are no blue droplets or very minimal blue droplets which are visible. The second one is HCC BCLC-A patient. So what you can see is a considerable amount of blue droplets, meaning that the patient has DNA which is hypermethylated in nature. And the last one, it's a BCLC-A, which means it's an early stage cancer. And HCC BCLC-C patient, which you can see again, is the sample is there's a good amount of hypermethylation can be observed through the extensive amount of blue droplets, which means if there is a patient who has HCC, there's a good possibility that the patient will have hypermethylation in specific genes. And not only that, the tumor burden also is directly proportional to that of hypermethylation. So go to the study that we have done. It's an observational study which we had done. It's 535 patients were recruited for the study, of which at the end of the removal, there are several exclusion criteria, and the consents were withdrawn, QC failure. What we were left out with was about 114 HCC subjects and 316 non-HCC subjects. Of the 114 HCC subjects, we had about 105 HCC below the age of 75 years. I will tell you why. And these were analyzed for assessing the test performance. The second thing was the etiology or the patient classification. So we had in both the groups almost all kind of etiologies. From ALD, the alcohol, HBV, HCV, NASH, or NAFLD. I mean, the proportion that was there for HCC was similar to that of non-HCC patients. And cirrhotic patients, there was about 70% cirrhotic cases in both HCC and non-HCC group. The 30%, again, it's almost similar numbers. So when we are talking about the case control study, like we have two groups, one without HCC and one with HCC. You are looking at a good separation with respect to the good equality with respect to the two groups. For BCLC staging, you can actually see 0 and A, which is the very early stage. About 40% of the patients were there in that stage. C and D, which was a very advanced stage, about 37%, and B, which is the intermediate stage, about 22.5%. Meaning there was a good amount of spread as well with respect to the staging of the cancer. So this is the clinical performance report. So you can actually see the episcreen liver the sensitivity was about 89% compared to that of AFE, which is the standard biomarker standard used globally, which hovers about 61%. So it was in the same study we did all these analysis. AFE and DCP were done at the center where the patients were recruited, and EpiScreen liver was done at our center. So, and the specificity hovers almost similar for both EpiScreen as well as the AFE, which is about 90%, whereas DCP, which is also called as PIVCA, was observed to be about 45%. When you combine EpiScreen and EpiScreen plus AFE, the sensitivity rose slightly to about 92% with a small drop in the specificity, which was about 87%. Technically speaking, this has an AUC of 0.91, and anything which is more than 0.9 is actually considered outstanding. So what we are looking at is not just a screening device, but a potential a diagnostic solution as well, as we have more data and as we collaborate with more hospitals and clinicians for this purpose. Going beyond that, this is a visual representation in three-dimensional space. So we have three parameters when we are doing this particular test. So you can see P1, P2, and P3 in XYZ axis, and the red dots that you can visualize are the HCC patients, the methylation parameters corresponding to the HCC patients. The black ones are the methylation parameters that is corresponding to non-HCC chronic liver disease patients. So you can actually see a good amount of spread that the methylation patterns for HCC guys is just coming out, whereas the chronic liver disease are just clustering in one corner. Now, coming to the age, as I mentioned, we have restricted our age to about 75, and above 75, the test performance actually decreases. You can see in the sensitivity graph. The three parameters that are depicted over here is EpiScreen liver, AFE as well as DCP. So EpiScreen liver, the sensitivity hovers about 90% till the age of 75. 76 and above, it drastically drops to about 40%. Whereas AFE, it gradually reduces from 62% to almost about 40% by the time the age of 76 and above. That's for AFE. And PIVCA, on the other hand, I mean, the sensitivity is about 80% from 56 to 65, but and it remains similar to even 76 and above. However, specificity, if you actually look at for PIVCA or DCP, it drops to almost 20%, which means there are a lot of false positive cases that come up if you're using DCP. The specificity for both AFE and EpiScreen liver remains similar, which is about 90%. This is a very nice way to monitor recurrence. So our test, basically, the way we have developed it is doesn't work only for screening. It works for recurrence monitoring as well. That is, people who have had HCC, it is possible for you to see when the recurrence is going to occur. Because normally in HCC patients, after any kind of intervention is done, the recurrence usually occurs within 2 years. And then the 5-year survival is also a little lower than other cancers. So you can actually look at the pre-intervention levels of both BCLC-C and D and BCLC-A. So the numbers were lower. Post 1 month, definitely it reduced because the epigenetic markers is directly proportional to the tumor burden. So if there is no tumor, there's not going to be any DNA which has hypermethylation. Unlike AFE or PIVCA, which is a function of function of the directly related to the function of liver. Meaning, I mean, the liver can act the way it wants to act. So, but over here, what you're looking at is just the DNA from the tumor. So post 3 months, there was nothing, and then post 6 months, you started seeing hypermethylation again through the blue observed through the blue dots. And we have actually checked with the clinician as well, and they indeed have had recurrence. So we were able to detect the recurrence almost 2 to 3 months before it actually happened. And it was captured in CECT. So, so that is one of the biggest things with respect to the recurrence monitoring and using our technology. The next one is treatment response marker. So we've done a pilot study with treatment response marker with about 15 subjects, and what we saw was about 90% of the patients, you could see the reduction in the methylation profile. So we have more data on that, and we have now collaborated with Gangaram Hospital as well in order to take this further and see how we can do it for a bigger patient pool and the types of therapies that's going to be there, loco-regional therapies, resection, transplant, or even immunotherapy. So we're going to be looking at that aspect and seeing how the hypermethylation is going to play a role. So that's one more thing. But the biggest thing that we think it's a game changer is a possibility to stage the liver cancer just by analyzing blood. So that's another thing what we have observed. Uh, we integrated AI along with our results, and you can actually see a nice clustering. So this is through k-means clustering, and you can actually see a nice clustering of the hypermethylation levels as against the BCLC staging. So the almost brown one, the green one, the pink one, they represent BCLC CD, BCLC B, and BCLC A0 respectively. And this was about 96.6% of the cases for BCLC 0A were matched in our case. That is, out of 31 cases, 30 cases were matched. In the C and D, out of 37 cases, 29 cases were matched, which was there in the cluster 4, which is, represents about 78.4%. But the thing is, it's not about matching the BCLC C or D. It's about what happens to those patients, because BCLC C or D still relies on about 25-year-old methodology of classification and doesn't have any kind of molecular signatures or parameters included in the staging process. So, and there has been a lot of talk going on for BCLC substratification as well, and trying to see how you can adopt treatment regimen based on the substratified patients. So most likely the prognosis for these patients who are outliers who come in the cluster, the blue cluster as well as the orange cluster. So we are looking at their prognosis, what they are faring. And yeah, so it's going to be more like a longitudinal study to see what's happening to that. We have also gotten, for this particular thing, the Young Investigator Award from International Liver Transplant Society 2024, Houston. And so we are amongst about 4 amongst the 1,000+ applications over there. So how does it work? It's a very simple, it's a very simple thing. The test is prescribed. It's about 20 ml of blood is collected in a safe DNA tubes. It's shipped to our facility. We extract the plasma, do the cell-free DNA estimation, do the deamination reaction, perform the droplet digital PCR analysis. Then we have a nurse algorithm that we've developed, wherein we 3 parameters is plugged in, and then it tells out whether the signals are detected or not detected. Will just come up later. And we share the report to the prescribing clinician. So it's RX only, and the 3 parameters basically are fed in to the algorithm, and the hypermethylation status comes out of that. So you have 3 things, which is detected, intermediate, and not detected. Detected is the one which is methylation levels in the same range as that of confirmed HCC patients, while not detected is that for non-HCC patients. So that's how it works. There are about 2% of the total population, study population, that we observed, wherein the methylations were between non-HCC and HCC patients, so we don't know. So that constitutes about 2% of the total population. So this is just a brief summary. So it's first of the kind in the world, and if you actually look at a specificity of about 90%, we have an early stage sensitivity of 86% and late stage sensitivity of about 93%. So which is pretty good considering this as a screening solution, and one of the first epigenetic based diagnostic solution for liver cancer. Multiple applications, screening, surveillance, treatment response marker, recurrence monitoring, and most likely it will go into cancer staging as well. And that's how the report looks like, very straightforward. There's no big bioinformatics involved. It's a very straightforward for any clinician or a patient to just take a look and say whether they are at risk of HCC or they are not. So I'm Srikar, and I have my colleague Durga. We are the CEO and the CSO and co-founders of Precision Cal. So we are involved with Professor Reila, Dr. Ashish Kumar for Gangaram. There are medical advisors. Dr. Ashwin, Dr. Dinesh, and Dr. Vasant, all of them have been our medical advisors. Dr. Sangeeta now is also a part of that, and thank her for that. Yeah, thank you.